Okay, last week we were looking at solving systems of equations, and we looked at one method of doing so, and that was by graphing, where we graphed both of the equations in our system, and we found the location where the x and y coordinate worked for both equations, and that was, of course, was the place where the lines intersected. Well, you can imagine that sometimes that might get a little bit difficult to deal with. Sometimes problems aren't that easy to graph, and we might want to find some alternative measure in order to do this. So today we're going to begin looking at solving them using algebraic techniques. And we're going to learn two major techniques that we use when we're solving systems algebraically. So again, sometimes instead of graphing, we may want to use an algebraic method. And the two main types of algebraic methods are the substitution method and the elimination method. And again, you may want to follow along in your notes as we go through this video. You'll see that your guided notes match up with this. So we're going to first talk about the substitution method. That involves using one value from an equation in place of the variable in another equation. This can be easier explained through an example, so let's go ahead and look at one. Here we have a system of equations, y equals 3x plus 1, and the equation negative 2x plus 2y equals 10. Now again, we could graph these two equations out and find the place where the line intersects, but as we've already discovered, most times we don't always like to graph, so we can use the substitution method here to do this. And the reason why this one is ready to go for substitution is such an easy method is we know that y is equal to 3x plus 1. So what you can do is you can go to the second equation and plug 3x plus 1 in for the y. So I'm going to take this negative 2x plus 2y equals 10, and I'm going to put negative 2x plus 2 times 3x plus 1 equals 10. And that 3x plus 1 that you see there in red is the 3x plus 1 that y was equal to from the first equation listed. And basically all we've done is substituted here, and this is why we call it the substitution method. Now the reason why we do this is we only have one variable in the equation now, and that is x. There is no more y in the equation. So we can do the distributive property and get 6x plus 2 there. And then we can combine like terms. Negative 2x and 6x go together and make 4x plus 2 equals 10. And we finish this out. We subtract 2 from both sides. We have 4x equals 8. And then we divide by 4 and find x is equal to 2. Now, that's just one of the variables. We have an x and a y that we have to find. But now that we know that x is equal to 2, we just plug that in and find the value of y. So probably the best place to go plug that in would be in the first equation, y equals 3x plus 1. So we know that y is equal to 3 times 2 plus 1. And again, that is because x is equal to 2. When we do that, we find that y is equal to 7. So the solution to our system here is 2, 7. X is 2 and y is 7. And again, we've used the substitution method to find the solution here. We use substitution by finding one of the variables, what one of the variables is equal to. In this case, we found y was equal to 3x plus 1, and we plug that into the other equation. All right, here's another example where we're using substitution. Now, in this case, we have to set up the substitution by isolating a variable first. Now, if you go back and look at the last problem, the y was already by itself. In this problem, there is no variable by itself to start off with. However, if we look closely, we may notice that the x in the first equation is a little bit closer to being by itself than all the other ones. So we may choose to get that x by itself in order to use the substitution method. So to do that, I'm going to take that first equation and I'm going to solve it for x. I'm going to subtract 5y from both sides, And now I've got x is equal to negative 3 minus 5y. Now at this point you may be asking yourself, why did I choose to get x by itself? Why didn't I get y by itself? Why didn't I go to the second equation and get x or y by itself there? And the answer is you could have. You could have done any of these. You could have found any variable here, gotten it by itself. The reason I chose x in the first equation was because that it had no coefficient. It didn't have any reason or anything else to stop it, and it was a lot easier to get that one by itself than any others because I wasn't going to have to do any division. If we get the y's by themselves or the other x, the 3x there at the bottom, I'd have to do some division in this case to do that and get a lot of fractions, and it's not something I'm necessarily going to want to do all the time. So in this case, since x was already by itself, I went ahead and got that one by itself so that I could work with it. Now, I know that x is equal to negative 3 minus 5y. I learned that from the first equation. So I'm going to go to the second equation now, and in place of the x there, I'm going to put in negative 3 minus 5y. So I've got that 3x minus 2y equals 8. I take the x out, and I put in negative 3 minus 5y. And, of course, I will now solve this equation. It only has one variable in it. I start collecting like terms and move some things around. I do the distributive property. Here in the PowerPoint, I've skipped a couple of steps, but we get distributive property would give us negative 9 minus 15y minus 2y. And then, of course, we would add the 9 over and get 17 on the other side. And we'd combine like terms, negative 15y and negative 2y would make negative 17y. So there we find that y is equal to negative 1. And again, I did skip some steps in solving that equation, but hopefully you can follow along at this point and find y is equal to 1. So now that I know y is equal to 1, I'm just going to go plug that back into the x equals negative 3 minus 5y that I had. So I have negative 3 minus 5 times negative 1. And of course, that's going to give me negative 3 plus 5, which is 2. And we find the solution to our equation is 2, negative 1. So again, substitution method, we're going to get a variable by itself. It can be any of the 4 variables listed. We get it by itself, and then we take that value that we get for the variable and we plug it into the other equation. And it gives us an equation to solve in one variable. Now, in looking at this, we can take that 2, negative 1 and plug it in. And hopefully you understand at this point, 2, negative 1 would make both of those equations true. And we can also find the solution by using a method that we call the elimination method. The elimination method is basically what it sounds like. We're going to eliminate one of the variables. In a system we have multiple variables. We eliminate one of those variables in order to make it easier to solve for the other one. And that is the method we're going to be applying here. So to use the elimination method, we have to get one variable to cancel out of both equations. And there's a technique we can apply here in just a moment. I'll show you. We'll do this by combining the 2 equations so that things cancel out. Here we can see an easier example that's pretty much ready to go for us. We've got 5x minus 2y equals 13, and we've got 3x plus 2y equals 11. Now if I combine these 2 equations, in other words, I'm going to add them together, the y's are going to eliminate. See, we add 5x plus 3x, that gives us 8x. When I add negative 2y and plus 2y, they cancel out. And then I add 13 and 11, and I get 24. So this gives us a much easier equation to solve. 8x equals 24, we just divide that out and find that x is equal to 3. So then, of course, you would just pick one of the equations. In this case, I've picked the second equation to go back in and plug that x value into. I know x is equal to 3, so I plug that in, and I get 3 times 3 plus 2y equals 11. In other words, that's 9 plus 2y equals 11. We subtract 9 and find 2y equals 2, and of course, y is equal to 1. So we have found x and y, and our solution, of course, is 3, 1. And this, again, was using what we call the elimination method. Now, the substitution method, we would have gotten one of these variables by itself and plugged that into the other equation. Here, we're just going to cancel something out by combining terms. We're going to combine the two equations and make something cancel out so that we only have one variable. In other words, we want to get the situation to where we don't have two variables, we only have one, so that we can solve. Let's look at another situation here. In this case, we have to multiply our equations in order to get terms to cancel out. So when you do this, you're going to have to find the least common multiple of the two terms that we want eliminated. Here's an example. We've got 3x plus 2y equals 13. We've got 5x plus 3y equals 20. Now, we're going to have to find something that can cancel out. So what we're going to do is we're going to multiply this top one by 3. And what we're trying to do, I'm just going to go ahead and say we're going to get rid of the y's. Okay, so if we want to cancel out y's, and we could have chosen x's to get rid of, but in this case I've chosen to get rid of y's, we want to find the least common multiple of 2 and 3. Those are the numbers with y. So the least common multiple of 2 and 3 is 6. So we're going to make both of them be 6y. We make the 2y turn to 6y by multiplying everything by 3. And we're going to multiply this bottom one by negative 2, so that would give me a negative 6y there. So in doing so, we multiply the top one by 3. We get 9x plus 6y equals 39. I multiplied every term there. And then we're going to multiply the bottom one, so that would give me negative 10x minus 6y equals negative 40. Now the key here is that I have a positive 6y and a negative 6y between my two equations. So when I combine these, they're going to cancel out. 9x and negative 10x make negative 1x. The 6y's will cancel out, and 39 plus negative 40 equals negative 1. So of course, if negative x equals negative 1, positive x is equal to positive 1. We take that and plug it into one of the equations. Here I've chosen the top equation, 3 times 1, which is what x is equal to, plus 2y equals 13. We solve that out by subtracting the 3 that we get. 3 times 1, we subtract that and get 2y equals 10. And of course, y is equal to 5. So when we solve that, we now have our x and our y solutions. So our solution for the equation, or for the system, is 1, 5. X is 1, y is 5. What we're going to do now is take a few moments and work on the practice problems. I'm going to give you a few moments to work with them. You might want to pause the video here, and then I'm going to kind of go through them with you as well. Okay, so now we're going to look at some actual examples that we had in the practice problems. I'm going to try and walk through some of these with you, and we'll discuss what's going on so we can become more familiar with the substitution and elimination methods. In the first problem here, we have x equals 2y and 4x plus 4y equals 18. Well, we're asked to use the substitution method. So we're going to look for the opportunity to get one of the variables by itself. Well, in this case, we already see that x is by itself. It's right there, ready for us to use. So we're going to take that and we're going to go to the other equation with it. We're going to take it down here, and here we go again. Give me just a moment, see if I can fix this. Okay, so let's try this again. As we said, we found that x is equal to 2y in this first equation. So we're going to take that and go and plug that into this second equation down here and make use of it to help us solve the equation. Now, I'm going to basically take this equation, 4x plus 4y equals 18, and rewrite it. And in place of the x, now I can put in 2y, because x is equal to 2y. We know that because we read the rule in our first equation right here. So we've got 4 times 2y plus 4y is equal to 18. As we start multiplying that out, that's going to give us 8y plus 4y equals 18. Oh, man. And we're running into some more technical difficulties here. Let's see if I can get it straight. 8y plus 4y equals 18, as we were saying. And that means 12y equals 18. So if we take that and work it out, we see that y is equal to 18 divided by 12, and that is going to be 1.5, or 3/2. Now, in doing that, we can see that y is not going to be a neat number, but we can take that and plug it in up here to this first problem, or the first equation, and find, since x is going to be equal to 2y, we have x is now equal to 2 times 1.5. Well, of course, that means that x is equal to 3. So we get the solution 3, 1.5. X is 3, y is 1.5. That is our solution. Okay, let's take a look now at the second problem down here, problem number 2. And we have another situation, x plus 3y equals 12, and we have x minus y equals 8. Now, as you can see here, neither of these equations has a variable by itself to begin with, like we did in the first set. But we do have some situations here where we might be able to easily get one of the variables by itself. I can take this x here, I can take this x or this y in the second equation, either one I like. Let's say we just stick to this and get the x by itself in this first equation. In doing that, that's going to be x plus 3y equals 12. Now, to solve that for x, we would just subtract 3y from both sides, as we've been doing with everything else. And that's going to give me a final statement of x is equal to 12 minus 3y. Now, that is going to be what we plug in to the x in this second equation. We took it from the first equation, so we're now going to go to the second equation and plug that value in for x. So as I do that, I'm just going to write, in place of x, I've got 12 minus 3y. And then we write the rest of the equation. That's in place of the x, and then I've got minus y equals 8. Well, as we start looking at this, 12 minus 3y minus y would be 12 minus 4y equals 8. We subtract 12 would be the next step. Minus 12, minus 12. I tell you, this thing never gets comfortable doing. At any rate, that's minus 12. And as we continue, we've got, that leaves us with minus 4y, or negative 4y equals negative 4. So y then is equal to 1. We take that, we can just go right here, plug that in. X is equal to 12 minus 3 times 1. And 12 minus 3 times 1, of course, is 9. So x is equal to 9, y equals 1, and our solution here is 9, 1. And again, that's the substitution method. We took one variable, we got it by itself, like we did right here in this step here. As we did that, we took the value that we got for that variable. We got x equal to 12 minus 3y, and then we took it over here and plugged it into the other equation for x. And we use that now Once we do that, we only have one variable in the problem, and we solved it for that variable, which was y equals 1. Okay, moving ahead, we're going to take a look at the other two problems now, in which we're asked to use the elimination method. Now, in the elimination method, we have to find something to cancel out, some means of canceling things out. So, in looking at this first set of equations in number 3, we have 2x plus y equals 23. We have 3x plus 2y equals 37. Now, you can choose to get rid of x's, you can choose to get rid of y's. As I look at this, I see a method that we might want to use. We might want to just multiply this top one by -2. In doing that, that would give me something here that would make that -2y, and it would cancel out with this one that I'm just going to multiply by 1 or leave the same, however you would choose to think about it. So we're going to do that real quickly. Hopefully my pen will make it through the video. But as I multiply this first equation by -2, that's going to give me -4x minus 2y equals -46. As I go to the bottom one, of course, I'm multiplying by 1. So that's going to work out real nice. It just basically stays the same. 3x plus 2y equals 37. Now, again, the reason why I chose to do that, if we look at what's going to happen, I'm going to combine these, and these two variables are going to cancel each other out. They're going to cancel each other out. -2y and +2y will make the y's be eliminated from this problem. So as we combine everything, we take -4x plus 3x. That's going to give me -x. And -x is equal to -46 plus 37. I believe is going to be -9. So we find that -x is equal to -9. That means +x is equal to +9. So we take that information and we're going to go right back to one of the equations from the beginning. Say we take it back to that second equation right there, since it's pretty close. And we've got 3 times x, except in place of x, we're going to put 9 in there. 3 times 9, and we multiply that, of course, and then we have plus 2y equals 37. Now the beauty of this is there's only one variable now. So we've got 27 plus 2y equals 37. Of course, 27 we subtract from both sides, and we subtract 27 here. And that leaves me with 2y equals 10. And a bunch of jumping around numbers that don't seem to want to sit still. But we got 2y equals 10. And of course, that's going to be that y is equal to 5. So if x is 9, y is 5. Is our solution here for this problem. Boy, this is getting real testy for me. But solution is 9, 5. X is 9, y is 5. Again, going through the steps, we found up here that we wanted to multiply this by -2 and keep this one the same. And in doing so, we got our y's to have numbers that would eliminate each other. Going down to the second elimination problem, which is actually number 4 in your packet, we have 4x plus 7y equals 6, and we have 6x plus 5y equals 20. And as we go and look at this, we're going to want to find something that's going to cancel out. We got to find some number that we can cancel out. Now, in looking at this, I know 4 and 6 can both go into 12. That's a good number that we can use there. You might find that you want to change the 7y and the 5y to both be 35. Whatever you want works, but you just have to be consistent with it. I'm going to use 12 on x's, so to do that I'm going to make this one going to be multiplied by 3, and I'm going to take my bottom one and I'm going to multiply it by -2. And in doing that, I'm going to get some things that are going to cancel out. So as we do this, we're going to get, for our first equation, we're going to have 12x. Make sure you see this is separated. We've got 12x plus 21y equals 18. I just multiplied every number in the equation by 3. Now we're going to multiply everything in the bottom equation by -2. So I get -12x, and you might be able to see what's getting ready to happen, minus, don't forget your negative here, 10y equals -40. And we combine the terms here, and as I do that, you can see that these two terms are going to cancel out. The 12x and the -12x are going to be gone. So there's no more x's in the problem. We're only dealing with y's. 21y plus -10y. That would be 11y. And 18 minus 40 is -22. So we can see 11y equals -22. Y is equal to -2 when you divide that out. And we take that and go back to one of the original equations to solve. So I'm going to take this bottom equation since I'm there. I've got 6x plus 5 times -2. And of course 5 times -2, and that's going to equal 20. So 6x minus 10 equals 20. Our next step would be to add 10 to both sides, so we got 6x equals 30. And of course then we find that x is equal to 5. So we get the solution 5, -2 here for this system using the elimination method. And again, using the elimination method, I eliminated one of the variables. In this case, it was the x from the first part of the problem. I eliminated x's by making them both 12, one with a positive 12, one with a negative, and they canceled out. So when I combined, I got 11y equals 22. That's only having a y in the problem now, and it makes things a lot easier to solve. We find the one variable there equals -2, and we plug that into the next equation, and we got that x was equal to 5. Okay, hopefully you've got a little bit of information here and enough to get started with working on a few of these on your own. Take some time. Make sure you got your guided notes completed for this section, and hopefully we'll get a chance to talk about this in class a little bit more.